This is the Cycle World podcast. I'm Mark Hoyer, the editor in chief, and I'm with Kevin Cameron, our technical editor. The topic today, Kevin calls it shaping the motorcycle. We talked about it. It is how did modern motorcycles get so amazing and affordable? And the obvious answer is mass production. You know, we can't all have craftsmen standing around miking everything and filing things to fit. I was watching a video recently from the Triumph factory. I've also seen a Harley video that's the same, black and white, 1950s, 1940s, touting, the manufacturing of modern motorcycles. And the guy is taking the frame with cast lugs and he's sticking tubes in it and putting it all together. And then he's standing in front of a table that's essentially looking like a forge, probably has some coal in it and it's, air fired. And he's dipping the joints in there and then he's putting like Sif bronze or, some other, gluing it together with metal, basically brazing it. And then he takes the thing out and because he's heated it and put it all over, he's smashing it with a hammer. He puts it on the jig and it doesn't fit. And then he just beats the daylights out of the hammer and puts it back in. And that's how we were getting motorcycle frames and Babbitt bearings, pouring bearings and scraping them till they fit the, like that's an Ariel Square 4. They were doing that on an assembly line, sort of.
Yeah.
It's crazy. And so part of the inspiration of this was thinking about modern frame manufacturing. That's kind of an anchor idea for us because the first motorcycle I know about that had a almost finished frame out of a casting mold that was bolted together at the steering head with permanent bolts that break off was the FZ07, the 2014 FZ07, a really affordable bike, particularly at the time, still affordable, with a frame that was, vacuum die cast, virtually perfect out of the mold, perfect size, almost no machining and no welding.
They call it net shape.
Net shape, and it just bolted together, and you had really nice finishes and a perfect frame, and the motor just slotted right in. And isn't that amazing? So let's, you say mass production democratizes technology, and ain't that the truth? So let's hear Kevin talk because he's good.
Well, in the La Belle Epoque, the wonderful years for very wealthy people between, say, 1875 and 1910, when wonderful handmade cars were available to wealthy people. So in this country, for example, a Pierce Arrow might have been $6,000 in those years, which would be in today's dollars $160,000. Now there are people paying $160,000 for cars, but I'm not.
Well, I was going to say, you said the good years when rich people could, like, that's kind of you can apply that to any era. So sorry.
Yes, it's true.
Carry on.
But you see some beautiful houses that were built that have all these rich wood paneling, and it's all been hand fitted together. And it's from more than 100 years ago, and it's never going to happen again. But along came Henry Ford. He started out making sort of conventionally bespoke cars, but in 1913, he combined the two ideas, interchangeable parts and a moving production line, which interchangeable parts mean no hand fitting, no filing, no tapping, no measuring, just slip it in and it fits. His car came off the line at about $850, which was an 85% discount on the Pierce Arrow. Now, over the next 10 years, he perfected the production line operation and he nailed his supply network. So they were able to get the price down to only 5% of what that Pierce Arrow had cost. That's an example of democratizing of goods by mass production. Henry Ford is supposed to have said that he wanted his factory workers to be able to aspire to own the cars they were making. So they were paid $5 a day, which made Ford unpopular with other employers in the area because their employees were saying, how about us? So mass production put a huge number of people to work and made a vast output of goods available. So, in that sense, the U.S. middle class, which has always been the powerhouse of the nation, was was just puffing up wonderfully as a result of the mass production revolution in this country. So methods that were highly advanced in 1913 are no longer that today. And as Mark was saying, motorcycle frames were made as bicycle frames used to be, tube and lug. On bicycles, sometimes the lugs are wonderfully filigreed and very attractive, and the tubes are fitted in, and the whole thing is furnace brazed. But the next step was to weld the frames together electrically, just as the Germans had welded U-boat sections together in World War II. When Rex McCandless went to Norton to build the chassis for the 1950 TT races, Norton said, well, we don't have any methods here other than electric. So he had to drag all of his low temperature silver brazing apparatus down from Northern Ireland and built the factory's frames there. Well, everything moves forward as time and investment permits. And around 1980, race bike frames began to be made out of aluminum, and they cracked constantly. It forced the people building them to refine their methods, to join the tubes gracefully, like tree roots join the trunk, rather than like two Tinker Toy sticks at right angles. And then we get into the later time when Antonio Cobas's twin aluminum beam chassis were first being used in racing. The steering head and the swing arm uprights and other fittings were individually machined from solid, and then they were welded to either fabricated sheet metal beams or extruded beams. That was obviously race team only. And then the next thing was to cast those elements, steering head, uprights, fittings. And finally, when the casting revolution took place around 1999 or 2000, which is described in that book by John Campbell entitled Castings.
Oh, it's a great book. It's what's good about that is he's British. You read it and you get a headache, but he also has a really delightful turn of phrase, and he quotes poets.
Yes.
It's a great book. It gave me a headache. I learned about it from you, and I have my copy, and it's got lots of scribblings in it. But you should talk more about the casting revolution because it's fundamental to where we are today.
Yes, it is. What he says in that book, in the outline, is that what had up until that time made castings notably weaker than, say, forged aluminum was that when the casting was poured, it was typically poured as rapidly as the structural integrity of the mold permitted and from the top. And as the liquid metal cascaded into the mold, it entrained air, and it also, the surface of the stream formed aluminum oxide, which is a ceramic. It's also an abrasive. And so these films of aluminum oxide would be swirling around in the cast metal, and as it solidified, they would be trapped there. And aluminum does not stick well to the films, which would fold over on themselves to form
Yeah,
what he called
think of fudge. Think of
bifilms.
fudge swirl ice cream, folks. And fudge is the oxide, and it doesn't stick together. You know,
Yeah,
it
so it's basically crack on dotted line. And when they researched the matter, they discovered this film formation. And they, of course, you try to do it with vacuum. Well, we won't let any air in there. But it turns out that even a tiny amount of air, which is 20% oxygen, is enough to form the films. They just love to combine with aluminum. And so they came up with the idea of filling the mold from the bottom where there's no air and doing it gently enough that there is no turbulent surface. So as the mold fills, the aluminum oxide film on the surface of the liquid metal rises and goes out the sprues at the top. And the result, when this is done properly, has been described as having near forged properties.
So what's important
Now,
about that is, well, sorry to
yeah,
interrupt, but what's important about that is the way we compensated with hand poured molds was to make things thicker to accommodate the potential weakness. And so
yes.
you had thicker, heavier castings, and now with the near forged properties, you can make a really fine casting that uses less material and is equally as strong or stronger.
Now, around the year 2000, during Daytona Speed Week in March, I spoke with rider Miguel DeHamel's crew chief, uh, Al Luddington, and he said, we're having a lot of trouble in the 600 class because the Yamahas are 32 pounds lighter than the lightest that we can achieve. And he said they're doing it with some fancy new casting method. Well, Yamaha has always been interested in casting technology, and they wasted no time applying it because machinery has a basic per pound cost. I audited a an automotive engineering course at the University of Wisconsin in the spring of 1966. And I wasn't supposed to be there because I was an anthro student, but that's what I'm interested in. So the professor says, all right, you guys, answer this question. What does machinery cost? And one by one, all the good students raised their hands and began complex and very correct explanations, which the professor waved away. And then I realized he wanted something different. So I raised my hand and I said, $1 a pound. Because at that time, a Cadillac was $4,500 and it weighed 4,500 pounds. A Bridgeport mill was 1,600 pounds for 1,600 bucks. And the professor said, you got it. Now, my little car, my little Korean job, costs the same as generic bacon in the supermarket, $7 a pound. The average car sold in America, $48,000, 4,100 pounds, $11 a pound. But if we look at the most sharply cost controlled of all motorcycles, namely Royal Enfield, we find they're starting at $20 a pound. So motorcycles are expensive because there's more moving parts and less pressed metal. So that means that there's a real reason to try to do without things. So when the CB750 was introduced, instead of having the 4 valves that Honda went racing with, it had 2 valves. Instead of having a pressed together roller bearing crankshaft like Kawasaki's Z1 and the new Suzuki's would have, it had a forged one-piece crankshaft turning in traditional automotive 3-layer bearing inserts. And because of the money saved by eliminating those labor-intensive technologies, they were able to make a motorcycle with electric start, overhead cam, and 4 cylinders. There hadn't been a production motorcycle with 4 cylinders before that.
Mass.
And lo and behold, CB750 outsold the 750 that Triumph and BSA had been struggling to produce, discussing it every different way and not doing anything about it until 1969, when they came out with the Triumph Trident and the BSA Triple. The CB750 outsold those bikes 10-1. Now, that's not a result of unfairness. That's a result of the free market at work. People wanted those advanced features, and they could have them at kickstart prices because Honda was using advanced production line methods of assembly and machining processes operating by means of an automatic transfer line. The part moves from machine to machine. Nobody touches it. It's already fixtured. The fixture goes click. The tool starts whirring, and nobody touches it until it's finished. So compare that with Granddad in his octagonal wire-framed spectacles with the micrometer pocket hanging from his leather apron. It's a lovely picture, but it cannot produce enough motorcycles for the people who want them.
Yeah, you can't have your accountant in the room if you're making things by hand.
And there are such things as cheap mass-produced junk. But mass production doesn't mean junk. It simply means what it says, mass production. And modern manufacturing methods have self-gauging, and it's all wonderfully constructed so as to put us out of work.
Yeah. Well, it's nice to be
a great job with the product.
Yeah, it's nice to be a hobbyist, and to have my old jack failed. I had a snap-on jack circa 1982, and I got it used from my friend who ran a shop, and it worked fine forever. It had never been apart, and then it started sagging. Wouldn't even hold its own weight up.
Oh.
And so I had to fix that jack. Well, I thought, I can go. It's so tempting. You can go down to any one of the mass chain stores. I can drive over here to, the store that sort of replaced Sears, we'll call it. And I can buy a pretty nice hydraulic jack, ready to go, low profile, long, rapid foot pump to get it up to wherever it needs to be. And then you hit it with the long lever. I get that for $300. And they're darn good. Last a long time. If you buy an equivalent jack that might be American made, you might spend $750 to $1,000. I could fix this for $40, but I had to make a tool on my mill, which I got for less than $1 a pound. Thank you very much, because it's used. But I had to make a socket to take the end of that tank off, and it took me multiple tries of measuring and getting it, because it's a gland nut and it's torqued to 490 foot-pounds. And so, anyway, it's great to be a hobbyist, but if you just need your jack to work, a lot of times you don't fix the old snap-on jack. You
just
go to
get a new jack. Yeah,
you just get the new one. So it's good to be a hobbyist, but I have great love and respect for the ability and the opportunity, should the need arise for me to go get that, or to buy a new motorcycle that doesn't drink as much work as a Velocette to keep on the road.
One of my favorite examples of how technology brings us advanced functions at prices that we can afford. I remember being wowed by being told that in the early 70s, MV's 350 Grand Prix bike was peaking at 17,000 RPM.
Amazing.
And I know that those bikes were entirely built by hand out of sand castings, and the crankshafts were pressed together out of multiple pieces so that they could have low friction rolling element bearings at every point. But in 2006, you could stand at the end of Yamaha's R6 production line and 17,000 RPM capable motorcycles would roll off one after another, and they had warranties, and you could buy them. They were what then? 10, 11,000?
Yeah, about 10 grand, roughly.
Yeah.
I mean, we had 600s running sort of 10 to 12 for quite a while.
Yeah. So that's my favorite example is that, and of course, people that I know in racing like to say that the production bike of today offers higher performance than the race bike of 10 years before.
Oh, Kevin
And
Schwantz was, they did a press launch with one of the GSX-Rs, and it was faster than the bike he had raced in the 200. He's like,
yeah,
I could have, if I had this street bike, I could have won the 200.
yep.
It is remarkable. We have to put an asterisk next to the RPM of the R6, because the first R6 that came out that had the astronomically high red line actually didn't rev that high. The rev limiter was cutting in early, so it was a little bit of marketing there, but they did ultimately settle on a very high RPM.
One of the things that's notable in manufacturing is that manufacturing methods change according to the number of parts that are desired. So if you're making a prototype crankcase for a project that you hope to hornswoggle money out of potential investors, there is this gleaming CNC set of crankcases ready for them to be impressed by.
It immediately makes me think of the Harley Davidson bagger race bike swing arm, because I forget what
Ooh,
it is. It's
yes,
like a
pretty
600 pounds of aluminum
pretty
that's
nice.
machined into this beautiful arch trellis. It's gorgeous.
Yamaha every year used to have a big disclosure when they talked about their MotoGP bikes, and they revealed that it took 70 hours of CNC time to produce the crankcase for their inline four racing engine. Now, if we reckon the machine at $200 an hour, that's $14,000 for the machining, and the huge block of aluminum is going to be another little chunk. So that right there says unobtainium. You can't afford this, but it can be a very good method for making six. So then you would have sand casting, in which partially manual methods, are used to assemble elements of a mold, which has bonded sand in it, and it also has passages for the entry of the molten metal and exit for the gases produced. And this method might be used for 100 parts. But to justify producing a die for die casting in a die casting machine, which is not a cheap item, you can only justify that if you can amortize the cost of the production equipment over thousands of parts. And
makes me
yes,
think of the CB750, because the early bikes, when they were probably still placing the bet, were sandcast. The early
yes,
750s were
that's right.
sandcast. Like, oh, maybe that was how it worked. I'm sure it's in a book somewhere. But oh, look, they're buying them. Great. Let's pull up that die casting. Let's go.
Yes, unleash it.
Yep.
So those um, different methods for different production quantities, and then you can add to that the possibility of flexible production. I believe Honda has spoken years ago of production lines that can quickly be switched to produce different models of parts for different models. And always bear in mind the difference between an assembly line, which is where all the parts are brought together and assembled. The engine comes in complete, the swing arm is ready, everything just slips together and with the screw gun. But actually manufacturing the parts, there has to be a die casting line, there has to be a machining line that produces the crankshaft, which begins as a one-piece forging. And it passes from one machine to another until finally somebody puts it into the crankcase, where the bearings, having a bit of assembly oil wiped onto each one, are waiting to receive it.
I was delighted to visit the Triumph factory on the introduction of the Bonneville, it was 2001. And we're going through, and right over in the corner of the shop was a plasma nitriding machine, and they were nitriding all the cranks.
Yeah.
On site. And then there I was in the assembly line, and the guys dropping the crank into the case. It was awesome. It's really neat. I remember the Kawasaki factory. I went to KHI, Kawasaki Heavy Industries. We did a tour, and we got to see them making trains and high-speed bogies. Bogie is the cart that has the wheels on a train. High-speed bogies for bullet trains, and it was magnificent. All the things that Kawasaki was doing, and then we went to the manufacturing line for the motorcycles, and there was a woman putting piston rings on pistons by hand, and she was great at it. A lot of the finer stuff on assembly lines or that kind of work is done by women. A little bit maybe finer motor skills, I think, is the thinking. But
Yeah.
she whipped rings onto a piston. I sit there and I'm like, don't break, yeah, come on, get on there. And she's just like, she has them hanging on her fingers, and she just goes whip, 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 and it's done. It was amazing.
Well, one of the things that also is of interest in manufacturing is the possibility of tailored materials. When Honda wanted to use titanium in some low production machines, they didn't just go to the titanium store and get the usual titanium alloy. They had an alloy prepared for them at a more affordable price, and which was not necessarily all specced out for military applications. In automobile manufacture, sheet metal has been getting thinner and stronger thanks to so-called HSLA, or high strength low alloy materials. It's very difficult to repair this stuff when you crash your car. It all has to be annealed before you can move it around.
Oh, forget it. No, it's that hardened stuff of new
Yes.
cars. That
Yes.
the idea of picking up your hammer and dolly and taking the fender of your
Forget it.
Pontiac back to flat, like you can hear it. Like I've tried. So on an old car, like I have an old Ford, English Ford Thames van, and I took a class from Ron Covell and got my hammers and dollies, these beautiful Martin hammers and an egg dolly, all these different shapes of dollies, and I started panel beating that Thames, and I was like, hey man, this is cool. Like I was able to smooth out these dents, and I could take creases and really flatten the creases. And then a buddy's like, "Hey, you do that bodywork stuff, man. My car is dented." And it was like a Chevy, I don't know, some 2001 Chevy or something. And I'm like, "Yeah, sure, I'll give it a try." And you could hear it when it hit, how hard it was. There
Yeah.
was no thud, no thud. It was like a crack. I'm like, bang, bang, bang. Nothing's happening. And
Yeah.
I suppose if I hit it really, really hard, maybe something would happen. But yeah, this is where you unbolt it and you put a new
Fit
one
new.
on, or
Fit
just
new.
don't move it and splatter on your body filler and call
Why
it
would
good.
they do that? The reason is, one, automobiles have to be made lighter so that they can meet the fuel consumption regulations. And two, automobiles have to have crush resistance so that they can pass impact testing.
And
So,
ultimately, you're using less material.
yes, less material, but tremendous resistance to crushing and deformation.
So less material is, I think, a very important point here because it cascades through the whole
It
operation.
absolutely does, yes.
Because if you make a beautiful die cast part that has only the amount of aluminum that it needs, it uses less material, it weighs less, and it's likely to be stronger. And so you're using less material in one. When you ship that, the shipping will be less. Like when you buy stuff from mass produced, like you go onto the website and you order your valise, you order your toolbox. It is manufactured in a way to fit into a box that costs less to ship. And so you get that with
Yep.
a part. You get that with a beautifully done cast part because then it's lower cost to ship to wherever it goes. It's easier to handle and it will likely last longer and perform better.
Royal Enfield in India, who are aces at this cost control business, as you can see, if you look at their prices and compare them with comparable models, I'm filled with admiration. Um, they are using something rather like your plasma nitriding setup in that it's in their plant. So rather than sending to Thailand to get tubular chassis made by a tubular chassis specialist, the Thai company designs not only the chassis, but a production system for it and sells that to Royal Enfield. They have it at their plant so that the chassis are not shipped.
Well, imagine making tires on site, right? No
Yes,
shipping. Like,
that was
you
what
have a
Metzler showed me. They showed me a machine that normally operated lights out, nobody in the room, nobody touches anything, can make 6 kinds of tires almost simultaneously. And every aspect of the construction of the tire is highly accurate because it's being done by these mad industrial robots. Imagine that you're standing at a tire machine 4 hours in the morning, 4 hours in the afternoon. You pull the ply off of the servicer of the machine that hands you the parts, and you go to the drum and you stick it on there, and you hope you've got it exactly right. And as you press the foot pedal and the drum starts pulling the ply out of your hand, you're guiding it and trying to keep it properly centered. All day you're doing this, you're going to pay good attention from 9 until 12 or 8
there,
until 12.
there
Um,
might be some variation.
and we want everyone to have a job, but do we want them to have that job?
Yeah.
Anyway, the Metzler people said it is our aim to be able to provide this machine to tire users so that the tires can be made as they're needed. So, hot stuff. Well, along came the Great Recession. We can't say depression, can we? The Great Recession of 2008, and motorcycle sales dropped 60%. Manufacturers got busy trying to restart their business. And at first, they tried novelties. They tried making all the stuff that the critics had been saying, why don't they make some of it sold? But it wasn't reconstituting the industry. What they found was that riders wanted the usual kind of motorcycles, the adventure style, the cruiser style, the super sports style, but they couldn't pay what they had come to cost. They talked about a 600 super sport bike being an entry level machine, and they were going for $13,000.
Notionally, entry level, but
Yeah,
yes,
they were
and
on offer for 13,000.
yeah, and insurance was
What
another
they did
issue.
was they cut their price by reducing parts counts, and that's where parallel twin engines have come from. Fewer cylinders, pistons, connecting rods, valves, and bearings.
And amortize, it's the universal power plant. It makes a beautiful torque curve, and they don't change the tune because why
It's
would you?
already wonderful.
It's a great engine.
Yes.
It doesn't make 132 horsepower at 17,000 RPM, but it's a great engine for most of us. And then they can put it into many models, and you just leave that same production line running, and just put them over here in your adventure bike, put them over here in your naked bike, etc. Put them in your fared sport bike, and you don't have to homologate it for smog in the same way, and all kinds of benefits there from the manufacturing side, giving us a lot of affordable, great motorcycles.
When I was quite a young man and became interested in Japanese motorcycles, um, after having been messing about with British motorcycles for some time, I there was a constant din in my ear that cheap Japanese stuff, you just don't mess with it. But when I looked at it, it looked well mass produced. It didn't have an irregular appearance, which would be the result of having it built by artists and people who think that the more mistakes there are, the greater the humanity of the product. These were turnkey electric start motorcycles of an entirely new kind that the world hadn't seen before.
Well, and imagine, I mean, the manual on some British bikes would say, if it's leaking out of the casting, take all the stuff out and peen the casting, because it was so porous that oil would seep through the casting. And the fix
Yes.
was take it all apart and peen it, smash it together to close the pores so it doesn't leak. Like die casting, I'm going to say that probably didn't happen.
Yeah.
It's just, I mean, it's just, it's insanity. And it's what happened to the British industry for one. I mean, they were making progress. The great TSS Triumph, 130 miles an hour, 4 valves per cylinder. One of the last Triumphs made, was supposed to be sort of their saving grace. Still parallel twin and recognizably Triumph, but it had modern features.
Yeah.
Too late, too little.
Yeah, you bet. Um, I decided to look into what costs what in motor vehicle manufacturing, and the the first the first glance you get says, well, parts basically account for at least half, and usually more than half, of the manufacturing cost, and labor is something around 20% or somewhat more. So if Royal Enfield's prices were low because they were underpaying their staff, they wouldn't be able to get the kind of price reduction out of underpaying people that we see in their selling price. Plus, Their plants are located where there's a Yamaha plant right up the street and a Hero Honda plant on the left, so that if people were underpaid, they could just take a walk and get paid properly. So, just as when I was a young man and I saw those early Hondas, the reason the price is low is because they're designed for low manufacturing cost, not for people who are, as you described, trying to put the tube and lug frame in the jig. Nope, won't go. Bam, bam. Try again. Hit it there. Finally, they get it to go in the jig. Pass. How long did that take? Several minutes, anyway. And they had to have someone detailed just to make up for their manufacturing errors. That's not a good plan. Another of my favorites is the Plaza Accords of 1986, when it was decided by the sort of Western powers that Japan must revalue its currency in order to do something about the balance of payments. Okay, with much arm twisting, it was done. But what was the result? Japanese companies quickly resourced a lot of parts from China. And if the Chinese company was not experienced in making those parts, they could get help. They could get training. They could buy production machines. So pay now or pay later. Uh, it's hard to make big cuts in the cost of things just by saying so. Another thing that interests me is that there are some new functions in late model motorcycles that people like. And I believe you were telling me last week that there's a 70% take rate on DCT on some Hondas offering that as an option.
It is. It's remarkable. It's Honda has done a lot over history. Honda's worked very hard to bring motorcycling to mass numbers of people, starting with the Cub. And all through the years, CB750A of the late 70s, wasn't a successful motorcycle, but they were trying even then. And it's
A for automatic.
Yes. It had a torque converter. It was
an actual 3-element torque converter. Yes.
Yeah,
which offers within itself 2 to 1 or more reduction. So,
but DCT was really, there was the FJ 1300A with an automatic, and that was a decent system. It was basically an automated manual, but DCT really worked. Like, it was the first automatic, aside from, like, there was the twin vane thing, the Aprilia Shimano 850. It had basically like a snowmobile or side-by-side belt drive in it, very variator elements and a rubber belt. And that was actually pretty nice to ride. It was not bad at all. But DCT really, really works. And the Goldwing, they came out with the Goldwing and they put DCT on it. It was on the NC 700. And, you're sort of like, oh, that's novel. I think, but we all ride because we like shifting. And no, in fact, we don't all ride because we do like shifting, and we are imprinted to enjoy it. But if I were buying a Goldwing, I would get DCT, and roughly 70% take rate on Goldwing. What I was surprised to find out, I recently asked Honda what was the take rate on the the Rebel 1100 with DCT, and that was surprising to me to say 70%. Wow.
Yeah. Now, of course, we know that 98% of automobiles are made with some form of automatic drive. So people don't necessarily know younger drivers don't necessarily know how to operate a gear shift automobile. And if that can be a barrier to motorcycle ownership. I've presided over people trying to learn it, and you have to be very methodical and very patient, and
And
people
resilient.
get it. People get it. But it is a hump to get over. Oh, I don't know if I want to do this. So the wonderful thing about DCT is, one, it is every bit as efficient as a normal gear transmission because it's transmission by gears. Two, you get the rise and fall in the exhaust note as the motorcycle accelerates, just as you do with manual shifting. So the auditory excitement is not lost.
Although I will say that when you put a Goldwing into automatic mode and you're like econ, when you're in your most mellowest mode, that it has a 7-speed. They put 7 gears in it to smooth out the lower end so that the gaps between the low gears aren't as wide as it is in a manual box. It's to smooth the shifting so that the speed, the relative speed is less between the gears, lower between the gears, so that and that way the dogs don't go kerkunk. It's much smoother, and that's why it has 7 gears. The bottom ratio and the top ratio are the same spread. They just put an extra in there. That motorcycle leaving a stoplight, if you're very mellow on the throttle, I swear by the time you hit the crosswalk on the other side of the intersection, you're in sixth, because also that engine has 108 foot-pounds of torque and I think it makes 102 at 1,000 RPM, 102 pound-feet. Very different tuning from, say, the BMW K1600, which was made to be a sizzling hot rod. I mean, beautifully refined and smooth. Goldwing was going for something different, and it will shift. Anyway, you're in 6th gear by the time you're on the other side of the intersection if you're riding mellow. But what you say is true, and the programming of that system is fantastic, because if you're in sport mode, it's holding gears. You charge a corner and it goes good, and it downshifts early, gets you up in the art. He's riding aggressively. Here you go.
Yeah.
It's very cool. It's cool stuff. And you get that beautiful flat 6 sound, and then the gear changes, like you say.
Conceptually, what a dual clutch transmission does is it breaks one of the 2 shafts in the transmission into 2 on the same center line, and each one has its own clutch. And the transmission is arranged so that you alternate from one shaft to the other as you upshift. And the clutches allow you to engage the next gear before disengaging the gear that is currently driving, because the clutches grip and release at exactly the right time so that there is no problem. This is quite wonderful. And I remember when I first saw DCT, I think it was on a Porsche, and they had the thing all cut away, and you could look in and shift the gears and see how the various parts performed their minuet. It was lovely. But of course, if your parts cost less, more parts cost more. So there's something. But another one of the new functions that really has my interest is variable ride height. I've known for years that people who like the look of an adventure bike buy one, they ride it for a week, they're back to the dealer. Can't you do something about this thing? I can't get my foot on the ground at a stoplight. So the dealer tells the setup kid, take care of this thing. And he cuts a bunch off of the spring spacer in each leg of the fork and gets around back and goes through that tedious process of winding the rear suspension down.
Well,
What happens? Yeah.
to the credit of many manufacturers, there are lowering kits that you can get on many bikes now, and
When you lower an adventure bike, you are removing some of the suspension travel. And the wonderful thing about suspension travel on an off-road bike is that it's the energy absorbing ability of the suspension is proportional to the travel squared. So what that has meant in terms of riding is that with longer travel, you can hit all those horrible things much harder now without being knocked silly, because the suspension can absorb that higher energy through having all that travel. So you lose some travel when you lower the bike, and it's not going to perform in its assigned task of off-road operation as well. But it's perfectly possible, because we see it in MotoGP, if anyone's watching, to fix the ride height so that it is push button controlled.
Or automatic.
You can fix it so that when the motorcycle is obviously rolling to a stop, the system says, aha, he's stopping, and it comes down so that you stick out your foot and there is Mother Earth. Now, is this unmanly? Is it improper? No, it's just possible. Anything that's possible is likely, and it has at last come to be, as on Harley's Pan America. And I believe there's one other manufacturer that's doing it too. So I like that, because it means that you don't have to be 6'4" to ride those very tall adventure bikes, or you don't have to look for a high curb that you can put your foot on when you stop.
Yeah, I mean, I guess it also brings up the point that there are more expensive motorcycles, right? We've been talking about parallel twins. We've been talking about mostly about sort of that end of the market. I mean, we've included CB750, but you have plenty of expensive motorcycle stuff that's, $15,000, $20,000, $30,000.
Yep.
But you're still able to get these features without it being, $150,000.
Yes.
You can get a great all around adventure bike that does so many different things. Ducati Multistrada V4s and spectacular, variable valve timing and, MotoGP like sounds and power in a bike that you can, bash around off road, and has spectacular traction control and all these things that ease your passage. And
ease your passage.
Well, that's really, with an adventure bike, we discussed testing, like how can we do a course for this comparison test, and you don't time that course. You have to use that subjective, like, can I make it, and how hard was it for me to make it?
Yeah.
Not how fast we could do it, because it isn't about speed necessarily in an adventure bike. It's about making it. I want to go see this. A friend of mine, Bill Getty, JRC Engineering, he's a scoutmaster, and they took a scout on a hike, and they were off in the California desert and going to a mine, a really remote mine. So they were driving up off road, and then they were going to hike the last half mile to this mine in really, really rugged terrain. And what did they find at the bottom of a hill but a BMW GS? Abandoned. And abandoned because the man had been airlifted out with a broken leg. And so they noted all the facts about the bike and went back and got it and found the guy in a hospital recovering with his broken leg. And yeah, that's my bike. And they mined it out for him. It's about making it, like that guy could have been a really great rider, but maybe if it had been lower, or, I mean, there's just, could the electronics be better? It's just making it, when you're out there by yourself, you got to get to the top of the hill, I don't know, to get lunch. Like, how are we going to do it? So it's very cool to have all the features that make it more possible.
Yes, I quite agree. It's like the vibration thing. The first parallel twin that was produced in quantity was Edward Turner's Triumph Speed twin in the late 30s, and it was a 500. So it had relatively small pistons, and it weighed like a motorcycle. So, 350 pounds or more. So what you have to do is divide the mass of the pistons, which are yanking up and down, into the mass of the rest of it to get an idea about how much you're going to feel the vibration. So when they turn the 500 into a 650, the 650 into a 700 into an 832 or whatever that last Norton was,
Oh,
the
828.
ratio is changing in favor of the piston, which is why the Norton was given that vibration
Oh,
attenuating
isoelastics. Yeah.
system. Yes, isoelastic. Um, but at the dealership, if a person said it vibrates a lot, they would be told basically, man up. You want to ride a motorcycle or not? Motorcycles vibrate. Well, people aren't as ready to accept that now, and neither are the aluminum frames, because everyone thought it was a tremendous idea a few years ago. We'll get those out of work TZ250 Yamahas and toss the two-stroke engine out, and we'll put a 450 four-stroke motocross engine in. Great. Light. It's got all the brakes and all the racy stuff for road race, for a nice 500cc road race, sort of a spec racer. Oh, the frame's got a crack in it. Oh, well, it'll probably be all right. At noon, crack's a lot bigger, and there's two more. And basically what was happening was the 450 made too much vibration for that kind of frame. And that's why modern motorcycles have vibration attenuation systems, usually balance shafts. Even Harley's big twin had to have them eventually. And I think this is just fine. I think that idea of manning up and getting used to vibration is like manning up and getting used to chronic pain. Hey, let's all go to the pain studio and hurt for a while. No, we don't have to do that. We have the technology.
Yeah, it's interesting. Harley came out with the Twin Cam 88B circa 2000. So that was the Twin Cam 88 balance motor that they were putting into Softails because they were solid mount. And then later on, even with the rubber mount motors in the touring bikes, they were putting a balancer in to tune it to keep the rubber mount and keep that relationship that we're accustomed to from a rubber mount Harley, because they have a feel and they have a personality from that. But they were tuning it. They made it too smooth, experimenting. They said, well, let's really smooth it out and see what happens. And people were like, no, I don't want that. Because they want
Yes.
they want a little bit of, you want that positivity. And it's just like keeping eliminating the noise to keep the music, which was the Harley line about quieting transmissions and putting helical cut gears in their gearboxes. Like in 08, the fifth, I think it was 08, the fifth gear was straight cut on the touring bikes. And by, I think, 2010, they had to change it to a helically cut gear because fifth was too noisy for the customers.
Yeah.
They were noticing. And so you're constantly trying to, control cost, but keep your customers happy.
Well, this is, of course, it's very important that the character of the product don't mess with that.
Oh, yeah, of course.
Because
yeah.
if your customer can't recognize the product, there's no relationship and no sale.
Yeah, I think about the Turner 500 Twin as being a pretty good example of making some progress for the end user and making a twin, but using not too many extra parts. There's no center support on the crankshaft.
Yeah.
It's a twin, as twin cylinder, but as you would call it, a jump rope. It's just held on the ends, and the two pistons are, orbiting around, and it works fine if you're not trying to make 132 horsepower out of your 750.
Yeah.
But once you start, it gets a little tough. You get a lot of One of that elephant's ears flapping, I think, is what.
In
Because
the
that's a Bruno de Prato line, I think.
yes, it is Bruno's. Yes, in the heyday of Meriden R&D, they ran. They
Sorry to
were able to
laugh.
qualify their 9,500 RPM 500 twin with push rods for GPs, and I would like to hear a Triumph 500 at 9,500 RPM, and it has been done.
Yeah, probably. You could probably hear that for a few minutes anyway.
Yes. But of course, at one point, I think it may have been Royal Enfield. They said, well, we want to make a parallel twin, but we'd like a center bearing. And they
Yeah,
were
there was
told,
pretty sure it was the Interceptor for
they
750.
were
Yeah.
told, we don't make a machine that we can guarantee concentricity of 3 bearings. Now, I don't know if that can even be true because automotive engines have 5 bearings in a 4-cylinder. And you would want to have, ideally, 3 bearings on a 2-cylinder. But
Well, there
it
were
was
plenty of inline fours. I play mostly with old British stuff. So Ford console 1703 that was used in the Thames van, and the console car had
the 3
three mains.
bearings.
3 mains, yeah,
Yeah.
and MG like MGAs earlier MGBs had 3 mains, and then they went to a 5 main later on.
I drove into a gas station in my hometown on a trip home, and I thought, oh, I could fill up. So I pulled in to the gas station where I knew the proprietor, and he came out, started putting in the gas, and he said conversationally, what is this thing, a V8 or a bearing thrasher? I love that expression, bearing thrasher. And if you look at the Cyclone, the overhead cam board track racer of 1915, had such a row. I think there were 2 bearings on the timing side and 4 rows on the drive side, all in an effort to prevent the flywheels from doing that elephant ears flapping deal, and also to prevent the bearings from wallowing out of the crankcase halves. Something that I think you've had experience with your Velocet.
Yep. Yeah, I had a look at the Cyclone that sold at Mecum in Las Vegas for about $1.2 million, and it was a
People
thing of
just
beauty.
love that thing. But
It is gorgeous. It really,
Reading
truly is.
Standard built one. Um, the Excelsior guys built one. They weren't fast. And that made me think of AJS, who switched from OHV to overhead cam and didn't get a power gain. So they went back to push rods for a short time. And what has been decided about that was that when they put in the overhead cam setup, they used the same cam forms as before, but now the valves were actually following the cam lobes instead of lofting over the top and providing a lot of extra intake area. So I think there had been times when a company has built an overhead cam engine and not benefited from it. Because, and of course, the company making Cyclone closed up later in 1915, I think. So it just needed some R&D to help it along. It had local success, but it faded out. And I think Reading Standard and Excelsior didn't get anywhere with theirs. Nothing wrong with the idea. You just have to develop its ability. You have to use its ability to control valves more abruptly because there's less mass in the system. Well, we've come a long way from shaping the motorcycle.
Indeed. Well, we can thank mass production and all the things that go with it, progress in materials, progress in thinking unconventionally, making tires on site, making frames on site, doing what it takes to bring the cost down so we can all enjoy a freedom of movement that is unprecedented in
And
humankind,
exciting.
and exciting, rewarding, feels good.
Yes.
Riding is amazing. This podcast is brought to you by Octane Lending, our parent company. Click that Prequal Flex link down there if you want to shop and get pre-qualified for a loan to buy a motorcycle. Give it a shot. Click the link. Makes a difference for us. We appreciate you joining us as ever. We appreciate the 7,600 comments that have accrued on all of our podcasts. And I have endeavored to read every one of those at some point. So keep them coming. Thank goodness that took me a year. So,
Yes.
but we appreciate you listening, and we will catch you next time.